Hello, girls. How are you doing? I know I'm not going to get a response for this, but I hope you're doing well. I know that this worksheet and this topic is a little bit challenging, so we're going to spend some more time on it. And today for lesson, I mostly want you to go back through this worksheet that I gave you and make sure you understand every single of these problems. So I'm probably going to give you a couple more just to make sure that we actually get it. So I'm going to go through, I think, most of these problems just to make sure. So I will ask you to go through your own worksheets and correct it and make sure that you understand your mistakes. So let's get started. So the first one, I actually think you got most of it fine. So if you remember, what's important about the rational function is that the denominator is not zero. So let's try to see when it would be equal to 0 and just remove this from the denominator. So it would happen if x is equals to 4, meaning that your domain is going to be x is every real number except for 4. Just like that. Because remember, if it is equal to 4, then it gets 1 over 0, which is impossible. So that's not too bad. This one should also be fine. If you remember, for square root, you need everything that's under the square root to be bigger than or equal to 0. So x should be bigger than or equal to 4. And that is your domain, simply. We're not going to make it too complicated. Now, this is where things get real. Okay, so now let's think about this. So we've got two parts in this, right? And most of you have actually identified that. So there's 1 and 2, and then we're going to do them separately. So I agree with that. So, but what I think I saw actually is most of you only did the first one, and you didn't do the second one. I'm not too sure why that happened. So, no, not 7. This is supposed to be 0. So you need whatever's under the square root to be bigger than 0, and that has to be the case for each of these square roots. So x minus 7 has to be greater than 0, meaning x has to be greater than or equal to 7. And then for the second one, 7 minus x has to be greater than or equal to 0. So in this case here, the x is going to come on the other side. So it means 7 is going to be greater than or equal to x, or it makes a little bit more sense for me when it's in the other direction, just like that. So now what I'm going to do is I'm going to go ahead and put this on the number line, because listen to me, and this is super important. These two things have to happen at the same time. So it's essentially like when we did sets before, we're taking the intersection between these two sets. We want to know where this x minus 7, no, x bigger than or equal to 7 and x smaller than or equal to 7 are going to intersect. We're going to go ahead and look at that, okay? So I'm going to make a number line just so that we can see it visually. So for the first one, so we have 7 in each case. First one, we know that it has to be bigger than or equal to 7. So it can be equal to 7. So here's my full circle. Okay, it's a little bit difficult to make a full circle on this thing. Let me see if I can just make like a huge dot or something. Okay, you see that this is a full circle, I hope. And then it can be anything after that. So anything after that will work. So this is for my first one. I should have used colors. Let me actually, I don't know if I can highlight this. No, I'm going to use blue, okay? Blue for this first one. This first one is in blue. Okay. And then for the second one, it has to be smaller than or equal to 7. So again, it can be equal. So I'm going to head and put this big one here. And then, but it has to be smaller than that. Okay. So now my question to you, which I'm actually going to write because it's super important, is where do they intersect? Intersect means that what points are in common to both of these lines? Where do they intersect? Do you see it? No response again. It's a little hard to teach your computer, not going to lie. So the only point that these two share together is 7. Do you see that? So if I put 7 inside of my function, so if I ask the function, let me see if I can move this down. Yeah, we're totally asking the function. What's f of 7? So we go ahead and we plug 7 in there. So we get the square root of 7 minus 7. And then we add to this the square root of 7 minus 7. What do we get? We get 0, because we get the square root of 0 plus the square root of 0, which is just 0 itself, huh? But if we would pick any other number, for example, if I pick 6, okay? So let's check what happens when I pick 6. So if I pick 6, which should work for the red line, huh? So we're going to get x, so it's x minus 7, so 6 minus 7, and then plus 7 minus x, so 7 minus 6. So we get the square root of minus 1 plus the square root of 1. Do you see that this is a problem? We cannot have the root of a negative. So it means the function doesn't exist at 6. It doesn't exist because this first root doesn't work. And then if I would pick, for example, 8, then it would be this root that would, like the second root that wouldn't work. The second root would give you a minus 1 also. So the point is, if I pick any other value than 7, the function doesn't exist. So what's the domain? The only value that exists for this function is 7. X equals 7 is your only possibility for both roots to work at the same time. I hope that makes a little bit more sense. This is pretty important and pretty challenging, I'm not gonna lie. So let me go ahead and do the other one also. So it's a rational function. Asking to you, try to think about it. What do we want from rational functions? We want the denominator to not equal 0, right? So let's go and check when it's actually equal to 0. That's wrong. So it's actually going to equal 0. We have solved a million of these problems before. You just don't remember it. So here we have a quadratic. To find out when the quadratic is equal to 0, what do? You know that, right? We've done things like this before. So you want to factor it. Or use the quadratic formula, but factoring is going to be easier. This is a super easy one to factor. You get 4 minus x squared, not 4 minus x only like this. So 2 solutions, x equals 0 for the first part, and then x equals 4 for the second part. So these two values will make the denominator of the p of x equal to 0, meaning that your domain would be every number except for these. Except for 0 and 4. This is our answer. If there is anything else in there that you don't understand, I will suggest you rewatch this video as many times as it takes for you to get it. And if that doesn't work, let me know and I will do my best to explain it another time. Keep me posted.